Okay, so this is going to go over a couple of lingering problems that we've been looking at, either already looked at or I promised to look at. So one of them is off of the probability details homework that you turned in, and it was number 2D. And it was really the only one of the papers that turned in that had some questionable issues on it. So we'll look at it, and there's really a couple ways to approach this. The question was, after n school days, the probability that Samantha goes to school by bus at least once is greater than 0.95. Find the smallest value of n. So we're trying to find the probability that she goes to school by bus at least once, which is greater than or equal to 1. And we want that probability to be greater than 0.95. And we're trying to find how many days. So n is the number of school days that she's going to go such that it is greater than 0.95. This is a greater than, not a 7. And what we do know is that, and I'm going to double check this, I'm pretty sure, yep. We do know that there's a 0.34 chance that she goes by bus, if I'm looking at my work correctly from earlier on. Boom, 0.34, yep. Which means there's a 0.66% chance that she does not go by bus. And that's going to come into play and help us in a minute. So there's two ways to do this. One is to, anytime you see at least 1, and that's exactly what this has in here, is at least 1. And when you see at least 1, you can change that into, so this is at least 1, you can change that into 1 minus the probability of none. And we want that to be greater than 0.95. So this is none of the times that she never takes the bus. On any of the days, she doesn't take the bus. So here's that probability of not taking the bus, and we want that to happen an n number of times. So one way to do this would be to subtract that 1 over. So if I subtract that 1 over, and I'm going to leave this in here as it is, if I take 1 away from this, I have negative 0.05. And then I divide both sides by the negative. So this is probability of x equals 0. And if I divide by negative, that switches to less than 0.05. And then this is going to be 0.66. It has to happen n times, and I want that to be less than 0.05. And so the other way to think of it is this kind of a shortened version of that, and that is to say, okay, well, being greater than or equal to 1, I want it to be greater than 0.95. Well, the opposite of being greater than or equal to 1 is being, the only thing that's not bigger than or equal to 1 is being 0. And if this probability has to be bigger than 0.95, then this probability has to be less than 0.05, or less than or equal to, either way. And you end up in this exact same place. And so this has to be the 0.66 to the n, has to be less than 0.05. And then in either case, you want to take a log of both sides to solve your exponential function. And I would take a log that's base 0.66. And the reason I would do that is log base 0.66 of 0.66 to the n less than log base 0.66 of 0.05. So I took the log of the same base. This n drops in front, and then I have log base 66 of 0.66. The bases are the same here, so this just equals 1. So I have my answer. N has to be less than log base 0.66 of 0.05. And this you can type in your calculator. And most of you, if you hit math, you can go down and change and find log base and do it that way. Or you can use the change of base formula that's in your formula packet. You could have taken log base 10 or natural log. You just would have had an extra division step. This is a direct answer in your book. And I believe this ends up being, this answer is 7 point something or other, I believe. So since n has to be less than that, I think the answer is 7 days. But you can double check. I don't have that. I don't have a calculator right in front of me, which is awkward for a math teacher, but that is the truth. All right. The second one that I want to talk about was on the soda problem that you maybe got through, but maybe didn't get to part G. So soda part G. This is one that's about the normal distribution. And this part on part G says the competing manufacturer. So this is all about filling cups with soda and a machine that fills it, overfills it, etc., etc. And so there's a competing manufacturer that says that not only will 98% of their glasses be safe from overflowing, so I'm just going to quickly start putting this on a normal distribution. So they're saying 98% will be safe from overflowing. So what that means is, like this is whatever the mean is right there, and overflowing happens over here, right? So this is like my overflow mark. And what they're saying is that this region, 98% of the times they fill a cup, it won't overflow. They'll be safe from overflowing. So really that's the same as saying there's a 0.02 out here, but 98% to the left. And we actually know when those cups overflow. We know this value right here is 16.7 ounces from an earlier problem. It told us that it overflows after 16.7 ounces. All right, so moving on. That's the first part that they gave me. Then it says 70% will have more than 16 ounces. Okay, so I don't really know what the mean is because that's what we're solving for in this, but I know if 70% have more than 16 ounces, that 16 ounces has to be over here somewhere. I don't know where exactly in relation to the mean, but it has to be to the left because that's telling me that all of this area in red, the red area is 0.7. So 70% of the time they fill it, it'll have more than 16, which is good because customers won't get mad about having a little bitty tiny bit of soda in their cup, and it won't overflow very often, which is good because then the company doesn't lose soda and make a mess. And the question is, what normal model parameters is this manufacturer claiming? And normal model parameters are the mean and the standard deviation, and we don't know either of those. So I kind of have to work backwards. So one thing I can do is I can do invert norm twice. So if I invert norm with my 98%, that's already on the left for me. So I invert norm 0.98, but I don't know my parameters, so I have to use 1 and 0 as my mean. And that's going to give me my z-score. That's going to give me the marking, the z for this 16.7 ounces. And if I do that in my calculator, I think I get 2.054. So this equals 2.054. So this equals 2.054. And so what I can do is I can use this other equation that we know, that is our z-score formula, which is z equals value of interest minus the mean divided by standard deviation. And I'm missing these two things, but if I have these two, I can start building an equation. So in my 16.7 overflow, using 98% to the left, and that x value and that z, I can write an equation using this. So I can have my first equation be 2.054 equals 16.7 minus the mean over standard deviation. And then I switch colors to red. And I also have to invert norm on red. Now, if I have a newer calculator, I can tell it that my 70% is on the right tail. But if I have an older calculator, I have to tell it that it's 0.30 because it expects me to be giving it to the left. So 70% or more have 16 ounces or more, then 30% have less than 60 ounces. And again, I don't know the mean and standard deviation, so I have to use a 1 and a 0. That gives me a z for this location right here. And that z is to the left of the mean, so it's negative. And I got negative 0.5244. So I can also write a little equation here, negative 0.5244 equals the x value of 16 ounces minus the mean divided by standard deviation. And then this doesn't look very fantastic, but if I multiply the standard deviation away from here and onto this side and do the same thing down here with the red one and put it on over here, so I multiply both sides by sigma basically, then I have in the system of equations 0.2054 sigma equals 0.7 minus the mean, and this would be negative 0.5244 sigma equals 16 minus the mean. And I could solve this system very quickly by subtracting the bottom. because that would eliminate the mean, and I would be able to solve for sigma. And I would get my answer for sigma, and then I could go back and plug it in. I think the answer for sigma ended up being 0.27. You may want to check. And the mean was 16.14 if you want to do the system of equations. But what you might notice is that what happens, oddly enough, and I'm going to do a little erasing here, and I have a couple minutes to show you that the standard deviation, in essence, if you want to do kind of an odd shortcut version of this equation, the standard deviation is going to be, if you want to solve it, it's going to be the change in your x values divided by the change in your z values. And what that means is these two here, my x values, my actual values of my soda differ by 0.7 ounces, and my z-scores, I erased the one over here, but it was negative 5.244. Those differ by about 2.5, I believe. So they differ by about 2.5781. So that's finding how far apart these two things are. And so they're just over 2.5 distance apart. That is how the standard deviation is. It's how many deviations there are for each of your changes in your actual x value. And if I come down here and I subtract these, so that becomes a plus, this becomes a minus, this becomes a plus, those are canceled. Notice that that's going to equal 0.7. That's going to equal the 2.5781, and when I divide away to get sigma, it'll be the 0.7 over the 2.5781. So this works. It's basically a shortcut of your system of equations. So if you have a normal model, you can find the change in the x's compared to the change in the z's that correspond to those x's, and that is your standard deviation, because the z's are counting how many deviations they are from the mean, and this is counting how far apart your actual values are from each other, and so you can calculate the standard deviation that way. And then again, you'd have to go back and plug it into your regular z formula up here to solve for sigma, or sorry, to solve for mu. Okay, that was the one that caused the most amount of difficulty on the soda problem, so I hope that helped a little bit, and that is it.